Dear students, welcome back. I hope you all are doing good. So almost after 1 month, I'm here again to teach you a new topic. So this time the topic that I'm going to start is lines and angles. You have already studied about lines and angles in junior classes, but we'll continue with that only. So first of all, we'll understand few basic terms about lines and angles. Although these terms you have already studied, but we'll just revise them. So first of all, collinear points. So what are collinear points? First is collinear points. Now remember, you can draw a straight line joining any 2 points. Any 2 points you can draw a straight line joining them. But in case of 3 points or more than 3 points, it is not necessary that you can draw a line joining all of them. Okay, so if 3 or more than 3 points are such that a straight line can be drawn joining all of them, then they are called collinear points. So always remember, collinear points, the term collinear points is only for 3 or more than 3 points, not for 2 points, because two points are always collinear, because a straight line can always be drawn joining two or more than straight line can be drawn joining 2 points. But in case of 3 points, only in few cases we can draw a straight line joining 3 or more than 3 points, and in those cases we call them collinear points. For example, suppose there are 3 points A, B, C like this, and you can see we can draw a straight line joining them A, B, C. Then A, B, C will be called collinear points. Okay. Now, what are non-collinear points? Non-collinear points. Non-collinear points are those points if 3 or more than 3 points are there such that a straight line cannot be drawn joining all of them, then they are called non-collinear points. For example, I will show you. Suppose point A is here, point B is here, and point C is here. Now you can see you cannot draw a straight line joining all the 3 points, that is A, B and C. If you join AB, then C will be left. If you join BC, then A will be left. And if you join AC, then B will be left. So you cannot draw a single straight line joining all the 3 points. So these 3 points are called non-collinear points. So I hope it is clear to all of you. 3 or more than 3 points, if a single straight line can be drawn through all of them, then they are collinear points. If a single straight line cannot be drawn joining all of them, then they are called non-collinear points. Clear? Now, what is an angle? Suppose there are two rays, one is OA and the other is OB. Suppose there are two rays, OA and OB. Now, and these two rays, they have the same starting point, same origin, same starting point. If there are two rays and they originate from the same point, then they constitute an angle. This is the angle between the rays OA and OB. Clear? Now, the OA and OB, they are called the arms. They are called the arms of the angle AOB, and this O is called the vertex of the angle AOB. Okay, OA and OB are called the arms of angle AOB, and O is called the vertex of the angle AOB. Clear? Now, there are various types of angles. The first one is acute angle. Acute angle. Acute angle is more than 0 degree and less than 90 degree. Acute angle is more than 0 and less than 90 degree, then it is called an acute angle. For example, I will make a diagram here. This angle you can see, it is more than 0 degree but less than 90 degree, so it is an acute angle. Clear? Now the next is right angle. Right angle, an angle which is equal to 90 degree. Right angle equal to 90 degree. If an angle is equal to 90 degree, then it is called a right angle. So it is, if an angle is equal to 90 degree, then it is called a right angle. Then the next is obtuse angle. An angle more than 90 degree but less than 180 degree. More than 90 degree and less than 180 degree. If an angle is more than 90 degree and less than 180 degree, then it is called an obtuse angle. So acute angle more than 0, less than 90, right angle equal to 90, and obtuse angle more than 90 and less than 180, then it is called an obtuse angle. So I'll make the diagram here. You can see this angle AOB here. This angle is more than 90 but less than 180. So this is an obtuse angle. Few more angles are there. Straight angle. Straight angle equal to 180 degree equal to 180 degree. So this angle is equal to 180, so it is straight angle. And then the next angle is reflex angle. Reflex angle, if an angle is more than 180 and less than 360. If an angle is more than 180 degree and less than 360 degree, then it is called a reflex angle. For example, first the definition is more than 180 and less than 360 degree, then it is called a reflex angle. If I make the diagram like this, you see A, O, B. So this angle, you see, it is more than 180 and less than 360. So this is a reflex angle. Clear? Now the last one, is complete angle. An angle equal to 360 degree will be called a complete angle. I repeat, an angle equal to 360 degree will be called a complete angle. So this is angle 360 degree. So this is complete angle. Clear? Now one more type of angle is there, and that is called, actually it is for a pair of angles, and it is called complementary angles. Now see, all these angles means acute, obtuse, right angle. They are the name of a single angle. But now this complementary angle, this is for a pair of angle. Now if two angles are such that their sum is equal to 90 degrees, then those two angles are called complementary angles. If the sum of two angles is equal to 90 degrees, then they are called complementary angles. For example, say 10 degree and 80 degree. 10 degree and 80 degree, because the sum of 10 and 80 will be 90 degree. One more example we can see 35 degree and 55 degree, because if you add 35 and 55 it will give you 90. So they are all complementary angles. Now supplementary angles. Supplementary angles, it is again for a pair of angles. Now when the sum of two angles is equal to 180 degrees, then they are called supplementary angles. So remember, when the sum of two angles is 90, then they are called complementary angles. When the sum of two angles is 180, then they are called supplementary angles. So supplementary angles, if the sum of two angles is equal to 180 degrees, then they are called supplementary angles or supplementary. Clear? Now if we give you example of supplementary angles, so here examples, say 30 degree and 150 degree, because if you add 30 and 150, the sum will be 180. One more example we can see 10 degree and 170 degree, because again 10 plus 170 gives you 180. So they are all supplementary angles. I hope it is clear to all of you what are supplementary angles are complementary angles. Next is adjacent angles. Adjacent angles. Now the definition is if two angles have a common vertex and one arm in common and the non-common arms lie on opposite sides of the common arm, then they are called adjacent angles. Then they are called adjacent angles. If two angles have a common vertex, one arm in common, and the non-common arm lie on opposite sides of the common arm, then they are called adjacent angles. Now I'll give you the diagram. See, AOB is an angle and BOC is another angle. Now you see O is common vertex for both the angles. AOB, the vertex is O, BOC, the vertex is O, so they have a common vertex O, and OB is the common arm. In AOB, OB is an arm, in BOC also OB is an arm. So OB is the common arm, and you can see the non-common arm, it lies on the opposite side of the common arm, so they are called adjacent angles. So angle AOB and BOC are adjacent angles. Angle AOB and angle BOC are adjacent angles. Clear? So they are adjacent angles. Now linear pair. Linear pair. If the sum of two adjacent angles is equal to 180 degrees, then they form a linear pair. If the sum of two adjacent angles is equal to 180 degrees, then they form a linear pair. Now I'll show you AOB and BOC. This is AOB angle and this is BOC angle. You can see O is the common vertex, OB is the common arm, and the non-common arms lie on the opposite side of OB. That means this angle AOB and BOC are adjacent angles, but as AOC is a straight line, so their sum will be 180, so they are forming a linear pair. Angle AOB plus angle BOC is equal to 180. The reason AOC is a straight line. And as AOB plus BOC is 180, then we can say that angle AOB and angle BOC are forming a linear pair. Angle AOB and angle BOC are forming a linear pair. We are forming a linear pair. Clear? Now it's clear what linear pair. Now vertically opposite angles. What are vertically opposite angles? Now see, if AB is a straight line and CD is another straight line, and these two lines are intersecting lines, means they are intersecting each other. AB is a straight line and CD is another straight line, and they intersect each other at point O. Then angle AOC and angle BOD are called vertically opposite angles. Angle AOC and angle BOD are vertically opposite angles, and this angle AOD and angle COB or BOC, they are also vertically opposite angles. Angle AOD and angle BOC are vertically opposite angles. Okay, so they are called vertically opposite angles. You have studied about vertically opposite angles also, and now I will prove it in a theorem that the vertically opposite angles are always equal. Means angle AOC and BOD, they are equal. Similarly, angle AOD and BOC are also equal. Vertically opposite angles are always equal. Now I'll tell you few axioms. So axiom 1, if a ray stands on a straight line, then the sum of the adjacent angles will be 180. You know, an axiom is where the proving is not required. They don't need the proving. You just have to remember it that if a ray stands on a straight line, then the sum of the adjacent angles will be 180 degree. Means suppose this PQ is a straight line and this is OA is a ray standing on this straight line. Now the adjacent angles will be POA and QOA. POA and QOA will be the adjacent angles, and the axiom says their sum will be 180. You know that as POQ is a straight line, so no proving is required here. So angle POA plus angle QOA will be equal to 180. Okay, that is axiom 1. Now axiom 2. Now in the axiom 2, if the sum of two adjacent angles is 180 degree, then the non-common arms form a straight line. So I think I have already told you about this, that if the sum of two adjacent angles is 180 degree, then the non-common arms form a straight line. It is the converse of this axiom 1. In axiom 1 they are saying that if POQ is a straight line, then the sum of these two angles will be 180. Now in axiom 2 they are saying if the sum of these two angles is equal to 180, then POQ is a straight line. Okay, and this axiom 2 is also known as the linear pair axiom, because actually the linear pair is this only. This is the definition of linear pair also. So the axiom number 2 is also known as linear pair axiom. Okay, now I'll tell you one theorem. I'll tell you one theorem, and the theorem is, if two lines intersect each other, then if two lines intersect each other, then the vertically opposite angles are equal to each other. The vertically opposite angles are equal to each other. If two lines intersect each other, then the vertically opposite angles are equal to each other. Now, in an axiom, no proving is required, but that is not true in case of a theorem. In a theorem, you have to prove it. Now see, suppose AB is a straight line and CD is another straight line and they meet at point O. Now you know angle AOC and BOD are vertically opposite, angle AOD and BOC are vertically opposite. Now you have to prove that angle AOC and angle BOD will be equal and angle AOD and BOC will be equal. Okay, so to prove angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. Now you see, first of all you write angle AOC plus angle AOD is equal to 180. The reason, you can see it is from the axiom 1, as CD is a straight line, so angle AOC plus AOD will be 180 degree. Reason you write COD is a straight line. Okay, as COD is a straight line, so we can say that angle AOC plus angle AOD is 180 degree. Then you write angle AOD plus angle BOD is equal to 180. See, angle AOD and BOD is 180 because again AB is a straight line. Again by axiom 1, as AB is a straight line, so the sum of these two angles will be 180. So reason again you write AOB is a straight line. AOB is a straight line. As AOB is a straight line, so angle AOD plus angle BOD will be 180. Now you see in these two equations, the right hand sides are same. So you equate the left hand side, means angle AOC plus angle AOD is equal to angle AOD plus angle BOD. Now you see angle AOD is cancelled. So angle AOC will be equal to angle BOD, and you see that is the first we have to prove. Angle AOC is equal to angle BOD. Angle AOC is equal to angle BOD proved. And now similarly you can prove the second part also, that angle AOD is equal to angle BOC. So I am not going to show it here. Applying the same method, exactly the same method, you can prove that angle AOD is equal to angle BOC. Is it clear? We have proved the first one, that is angle AOC is equal to angle BOD. Okay. Now we are going to do few examples based on these axioms and theorems and types of angles. Okay. Now you see in this diagram they have given that angle POM is A and angle XOM is B and angle XON is C and angle POY is 90 degree. MN and XY are straight lines. So you have to find A, B and C. Find A, B and C. This is the question. Now, first of all, okay, one more condition is given over here, and the condition is given A is to B is equal to 2 is to 3. The ratio of A and B are given. A is to B is equal to 2 is to 3. Now see, let A is equal to 2x, B is equal to 3x. First of all, as the ratio is given 2 is to 3, so we have taken A is equal to 2x and B is equal to 3x. Now what happens? Angle POY plus angle POM plus angle XOM is equal to 180 degree. The reason XY or XOY is a straight line. Okay, you see angle PO, angle POY, angle POM and angle XOM, their sum will be 180 because XOY is a straight line. Now POY is given 90 degree, so you write down 90 here. POM they have given A and XOM they have given B is equal to 180. Now A we have assumed 2x according to the ratio and B is 3x is equal to 180 minus 90. So 2x plus 3x, 5x is equal to 90. So x will be equal to 90 upon 5, that is 18. Now we have found x. So A is equal to 2 into 18, that is 36 degree. B is equal to 3 into 18, that is 54 degree. So we have already found A and B, and now we have to find C. Now you see, MON is also a straight line. That means according to axiom 1, B plus C must be equal to 180. So you write down B plus C is equal to 180. Reason you write, MON is a straight line. MON is a straight line, so B plus C is equal to 180. Now B you have already calculated 54 plus C is equal to 180. So C will be equal to 180 minus 54, that is equal to 126 degree. So we have found that value of C will be 126 degree. So A is equal to 36, B is equal to 54, C is equal to 126. Clear? That is your answer. So after this, we will do one more example. So the next example, okay. Now angle BOP is given X, angle AOP is given Y, angle AOQ is given Z, and angle BOQ is given W. Now the condition given is X plus Y is equal to W plus Z. Given X plus Y is equal to W plus Z. Prove that AOB is a straight line. You have to prove that AOB is a straight line. Now what we do, all of you know that the angle around a point is called a complete angle, and a complete angle is equal to 360 degree. That is X plus Y plus Z plus W is equal to 360. The reason, complete angle. Okay, so X plus Y plus Z plus W is equal to 360 because it's a complete angle. Okay, now the condition is X plus Y is equal to W plus Z. So in place of W plus Z, you write down X plus Y. So X plus Y plus X plus Y is equal to 360. Reason, it is given in the question that W plus Z is equal to X plus Y. Now X plus X, 2X plus 2Y is equal to 360. Divide the whole thing by 2, then X plus Y is equal to 180. Now using by axiom 2, we can say when X plus Y is equal to 180, that means AOB is a straight line. Okay, so as angle AOP plus angle BOP is equal to 180 degree, so AOB is a straight line. Okay, that is what we have to prove, that angle AOB is a straight line. Clear? Now we will do one more example. find two complementary angles, find two complementary angles in which smaller is 1/4 of the larger. Find two complementary angles in which smaller is 1/4 the larger. Let the angles are x and y. Let the angles are x and y. Now, as it is given that they are complementary, so their sum must be 90 degrees. I told you. That means x plus y is equal to 90. That is equation number 1. X plus y is equal to 90 degree. Then they are saying that the smaller one, let it be x, is 1/4 of the larger. It means 1/4 into y. The smaller one, that is x, is 1/4 of the larger, so 1/4 of y. If you cross multiply, 4x is equal to y. So this is equation number 2. Now using these two equations, we have to find the value of x and y. So from 1 and 2, in place of y, you put 4x. From equation 2, you can see y is equal to 4x. So put 4x there. X plus 4x is equal to 90. So 5x is equal to 90. So x will be equal to 90 upon 5. That is equal to 18 degree. So x is equal to 18 degree and y is equal to 4 into 18 will be 72 degree. So that is your answer. The angles are 18 and 72. You can see they are complementary also because their sum is 90 and 18 is 1/4 of 72. That means the second condition is also fulfilled. Is it clear? Now we will do one more example. If two supplementary angles are in the ratio 4:5, then find the angles. Then find the angles. Now they have given that the ratio of the angles is 4:5. Let the angles be 4x and 5x. Let the angles be 4x and 5x because the ratio is given 4:5. Let the angles be 4x and 5x. Now, as it is given that they are supplementary, so their sum must be correct, 180. So 4x plus 5x is equal to 180 degree. The reason you will write supplementary angles. Now 9x is equal to 180. So x is equal to 180 upon 9. That is 20 degree. That means the angles are 20 into 4, that is 80 degree, and 20 into 5, 100 degree. That is your answer. 80 degree and 100 degree are the angles. You can see they are complete, they are supplementary because their sum is 180 and they are in the ratio 4:5 also. I hope whatever I explained today is clear to all of you. So you have to go through the lecture, video, and then attempt all the questions given in the assignment as well as in your textbook. We'll continue in the next period with the same topic. Thank you.